Today, we'll learn Euler's theorem for complex numbers. This powerful formula connects exponentials and trigonometry. By the end, you'll see why e to the power of I theta equals cosine theta plus I sine theta. Let's first state Euler's theorem. For any real angle theta, e to the power of I theta equals cosine theta plus I sine theta. To see why this makes sense, let's draw the complex plane and the unit circle. On the complex plane, the horizontal axis is the real axis, and the vertical axis is the imaginary axis. Every point on the unit circle has coordinates cosine theta and sine theta. Now, let's pick an angle theta and draw the point on the unit circle. That point has x-coordinate cosine theta and y-coordinate sine theta. In complex numbers, we can describe this same point using magnitude and angle. A complex number with magnitude 1 and angle theta is written as e to the power of I theta. So e to the power of I theta is the same point as cosine theta plus I sine theta. Let's do a quick example. Suppose theta is pi over 3, which is 60 degrees. The cosine of 60 degrees is 1/2, and the sine of 60 degrees is square root of 3 over 2. So e to the power of I times pi over 3 equals 1/2 plus I times square root of 3 over 2. And that's Euler's theorem for complex numbers. It tells us that exponential functions with imaginary exponents trace out circles on the complex plane.